Good morning, everybody. This is the first presentation on this room, so I would like to welcome everybody here to my presentation. My presentation is different from the others, as you can see from this long title. So I want first to clarify it. Mainly, it's called Scientific Analysis of Collaboration Patterns in Open Build Service and Bugzilla, with a focus on the history of merging requests in factory repository in Open Build Service and the history of bug reports in our Bugzilla. So my name is Athanasios-Ilias Rousinopoulos. For those that they know me, I'm Zumbis. It's simpler than my name and my surname. And I'm a PhD candidate in Alpen-Adria University in Austria. So this presentation is part of my research in a software engineering research group. So why do I this presentation? Which is the motivation behind such a presentation? The main motivation is that in the past, I'm a member of the community the last close to 3 years. So we had rumors. We were listening or reading in the mailing list. There are a few people working on the reviewing process or accepting requests in an open build service, especially in factory. But all these were rumors. So we want to observe what's going on with the data. Is that true? Is that not true? Are there more people behind open build service and especially on openSUSE factory development? Then, as part of my ongoing research, which is dedicated to software repository mining, among with my professor, Martin Pinsker, we thought that it's a good idea to make a piece of research for the community and see what's behind the data. Apart from that, I thought that this could be helpful also for the community to know what's going on the development process, or for instance, if it's a good idea to reduce or increase the amount of months for the development process and or the ongoing work in openSUSE factory project. So, the goals of the work are to mine the data from openSUSE factory. This includes submitted requests in Open Build Service and also submitted bug reports in Bugzilla for openSUSE factory. Then, after mining the data, comes the analysis part. So what can we see, what can we observe, if this is useful for the community members or may also for the company. The other part of the goals is the correlation between the submitted and accepted requests in openSUSE factory with the submitted bugs or bug reports on Bugzilla. For instance, to see if a higher amount of submitted requests increase the amount of bugs submitted in Bugzilla. And finally, publish the source code. So everybody from the community can contribute and also reproduce results and also work with other open build service projects. Talking about data, it's good to declare what data did we mine. So we mined data for 3 years, from 2011 until the end, from the beginning of 2011 until the end of 2013, in order to have high range of data and make better observations. As I point out before, our work focused on the submitted requests on openSUSE factory repository in Open Build Service and on the submitted bugs on Bugzilla. So, Bugzilla. When I first started mining the data, my question was if people from community, they do use Bugzilla for submitting reports, especially for openSUSE factory, where at the same time they do contribute on their project on Open Build Service and submit requests in Open Build Service. So, we used a tool called Bicho, which is a tool for parsing issue trackers and Bugzilla, and stores the data in the database. It's an open source project, which is also available on GitHub, and you can download it. We mined 8 Bugzilla projects in our Bugzilla, and that consisted from 6 projects, which are Apache, KDE, Genome, base system, kernel, and XFC. From the 6 projects that we mined, I will present here 2 of them, which are KDE and Genome. So, after we mined the data, we show that there are not enough data in Bugzilla to make such a correlation. So we stopped the research or the ongoing work on this part, and we continued to Open Build Service factory, and more especially on the submitted requests. So, for that purpose, we developed a tool called OBS parser, which downloads the data from Open Build Service by using the OBS API command and exports the data in XML format. After that, the parser parses the data from the XML file, stores the data in a MySQL database. So for a user, for a developer, it could be easier to plot some graphs or type some SQL queries. So the next step was to define some matrices that could be also interested not only for the research but also for the community. These matrices are consisting of the number of submitted requests, the number of people who submitted these requests, so we can call them requesters or submitters, the number of reviews that have been done on these requests, the number of people who reviewed these requests, the number of packages of the project that we were examining, the people that accepted all these requests, and also the time difference between the moment that a developer or user submits a request to openSUSE factory until the moment that a developer or a user accepts these requests on Open Build service. Okay, here we can see all a data summary of the data that we mined for Genome factory repository and for KDE distro factory repository in Open Build service. So we can see that Genome factory has close to 25% more requests than KDE distro factory, but has close to 40%, close to 30% less reviews done by users. Also has less reviewers, but on the other hand has more packages, close to 27% of in comparison with KDE Distro Factory. On the other side, KDE Distro Factory has less submitted requests, close to 40%, as I said before, reviews done by reviewers, has 2 more reviewers, and close to 30% less packages in comparison with Genome Factory. So now we will see what's going on Genome Factory repository by following also the matrices that we have declared. First of all, this is a plot which represents the distribution of requests categorized per state. So this here we can see that the majority of the submitted requests have been accepted, where few of them have been revoked, and fewer have been superseded. So it's good to know that people submitted requests, but it's better to know who submitted all this amount of requests. As we can see in the plot, the core team of submitters, if we can call it, are 2 people who submitted more than 2,000 requests each. So the rest 8 people didn't overrate the limit of 10 or 20 submitted requests. On the other hand, we see the people that reviewed all these requests submitted on Genome Factory. The first 2 bars are the automatic response from Open Build service concerning the reviews for license compatibility and for build compatibility. So excluding these ones, which are the automatic responses, we see that 3 people are the main reviewers of the submitted requests. Before having a look on the details of the reviewing process, our question was if all the requests are being reviewed or they are being accepted directly from a developer. What we can see here is that more than half of the submitted requests haven't been reviewed but accepted. So this plot represents the amount of not reviewed and reviewed requests of the accepted requests. And we see a fewer amount, less than the half, that have been reviewed. Since we have people who submitted, we have people who reviewed the requests, now we have people who accepted these requests. By having a look, we see that also here we have 3 people who are the core team of accepting requests, since 3 humans. So if we don't include auto build, which is an automatic response from Open Build service, we can see that there are 3 people who are accepting the requests. And more especially, the other ones do not override the limit of 500 accepted requests. So the next step was to see how many time is being spent between, or what is the time difference between the submission of a request and the acceptance or the clients of request. For that purpose, we want to represent the history part, which is also available online, but we wanted to store this information in the database. So somehow we represented the log of the request. So first, the developer submits a request, then there are some reviews, or there are not reviews as we saw before, and then somebody accepts the requests. In case of Genome Factory, we see that 7 to 10 requests are being accepted in less than 24 hours. There is a high amount of requests which is being accepted in 1 day, and the other requests. Oh.
Can I ask a question?
Yes.
Those 74, does it include the ones that were not reviewed at all but immediately accepted?
Yes.
Okay, so of the ones that are actually reviewed, the percentage is much lower.
Yes. That's true.
Can you repeat the question? Because it's also on the
Question? Which one?
You should repeat the question. Repeat the question from the microphone.
Oh.
The question I asked, repeat it in the microphone. I can do it. Okay. The question I asked was if this 74% also includes the requests that were not or barely reviewed, as you show in the earlier chart.
Is that work?
Yeah, it works.
Yeah. I think
It's on.
Okay. Here we see the requests that are also being reviewed and not being reviewed. Okay. So the answer is that here we see the requests that are being reviewed, but also not being reviewed. So the acceptance time for only the reviewed requests would be different. I'm just making an assumption. So the next part is what is going on with KDE Distro Factory repository. We just followed the same way, the same procedure for mining the data, storing the data in the database, and gather the same matrices. So here we see that there is a higher amount of superseded requests in comparison with Genome Factory, where the revoked requests remain exactly the same, and the accepted request, the amount of accepted requests is being reduced. As before, we see the people that submitted the request to KDE Distro Factory repository, and we see that 4 of 10 people are the main, the core team of submitters. The rest of them are submitted less than 300 requests. The same one with the reviewers. We see that 3 people are the core reviewers of KDE Distro Factory. Since the first 2 bars represent the automatic responses from the system, and the other developers made less than 1,000 reviews. In Genome Factory, we saw that the not reviewed requests are more than the reviewed requests, but in KDE Distro Factory, we observed that the number of reviewed requests are more than in Genome Factory and are the majority of our data, where in the other hand, the not reviewed requests are less than 15%. Here we see that two people, we can call them the core team of the acceptors, the people who accepted the requests. But among the two people that are accepting the requests, there is a high difference where the first one of them accepted more than 7,000 requests. And the other ones accepted less than 100 requests. Since we had different data with reviewing and the reviewing process and the reviews that have been done, we have different data in the time that developers and users spend it to accept a request. So here we can see that less than the half of the requests have been accepted in less than 24 hours. There is a high percentage of accepted requests within a day, also within 2 days, and until the limit of 10 days, we have also accepted requests. But the majority are less than 24 hours, more than 24 hours, and less than 48 hours. Okay, we made this study, but as I defined in the goals part, our last goal was to publish the source code and so the community can interact with it. So, the source code is in alpha version. And is available on GitHub. So if you go on GitHub and search for OBS parser, you can find and clone the source code and also reproduce the result. Like every presentation, each presentation, we made some conclusions, and these conclusions, they do consist of that if people submit more bugs on Bugzilla, it could be possible to correlate the accepted requests with the number of bugs in openSUSE factory distribution. Apart from that, we saw that the same people could submit a request, review a request, and then accept the request. But also we saw that the people who accepted the request in the two projects presented, the core team is exactly the same. Then, as I mentioned before, we saw that there is a high amount of non-reviewed requests in one of our projects that we study, which could have some impact or not. We just made an observation of the data, and we present them here. Since we don't have any data, enough data from Bugzilla, we can't say if this is bad or good for the project. And now comes the question part.
Will the tool be able to, for example, review the time and the metrics between opening a bug and getting maintenance requests done and published inside the maintenance, so we can show how fast or how slow we are, good or not, to fix a bug on a released repository, for example, for 13.1 or next 13.2.
Yeah, actually there are two tools. So the tool that mines the Bugzilla can give this kind of matrices when a bug is submitted and when a bug is big, solved or marked as unsolved, or change the state of the bug.
Yeah, because normally actually we have the bug number inside the submit request for the maintenance, which is again automatically reported inside the bug. So I think we should be able to cross-link those two information.
Yes, but for this purpose I have to parse the change history, which is not, which I didn't, not yet done, yeah. Not yet, yeah.
Tomorrow.
Yeah, tomorrow, we can start tomorrow, of course.
What was the exact problem that prevented you from mining the Bugzilla data? Too little bugs or something missing?
Too little bugs for 3 years.
Just for the missing bugs, it is because it's a category about when we say, oh, I found a bug about against Apache or KDE or something like this. Is it a category inside Bugzilla that are not really linked to the different project we have on OBS? Or it's just not enough data, not enough bug reported by users?
The structure of Bugzilla gives a product called openSUSE factory and then gives components which are called Apache, KDE, Genome. So we assume that the people that had that have a problem, that found a bug on GNOME apps, for instance, they will submit this bug on the Genome component in Bugzilla. We made that assumption to aggregate the data. Otherwise, it wouldn't be possible to say, okay, this is bug for this project and find exactly the same project in open build service. To say, okay, we have 10 bugs in Nepomuk, for instance, but we don't have a Nepomuk project on open build service, or we have 2 or 3 projects. Repositories, excuse me. Two minutes, yeah. Yeah, but I'm done. Yeah. So if we don't have any other questions, I would like to thank everybody for attending my presentation and giving feedback and their questions.